Lunati. Is him online, Marco?
Yeah.
Andrea, do you want to introduce his work very, very briefly, just to...
Yeah, well...
he's sharing his camera.
Yeah. Marco, now you should have the right to present. So please start. Okay. Okay, so thank you so much. So the thesis work proposed by the candidate, in this case, analyzed the complex theme of energy simulation, applying it to case studies. The objective in this case consists in the informed use of different calculation approaches, both dynamic and semi-stationary, and a comparative result analysis for the different building use profiles. The work is very concrete and in accordance with some professional needs born during an internship activity carried out by the candidate at the National Thermal Insulation Association, AMIT. Okay, good luck.
Okay, so good afternoon. I'm Marco Lunati, and my dissertation is on calculation methods for building energy simulation, and in particular on potentialities and output fields of application for this type of method. So this work was part of an internship program at Unit. After following experts in an energy audit on a residential building, the focus moved to the study of semi-stationary and dynamic calculation methods, and had the chance to test the Unit software programs, in particular on 2 case studies. The first, that was the previous re-elaboration of the previous energy audit, gave me the chance to test and validate the model results with the benchmark of the real consumptions of the building. The second was more a work of analysis of the many dynamic potentialities on another existing building with tertiary use. So, as the climate change problem has been increasingly capturing our attention, the interest into the energy field started to be accompanied by another concept: sustainability of transportation industry, and which absorbs up to 40% of the final global energy in Europe. The countries which signed the Framework Convention on Climate Change meet every year at the Conference of Parties. In particular, the Kyoto Protocol of the COP3 inspired the European Union to produce the so-called Energy Performance Building Directives in order to improve the energy performances of the building sector in the community, implemented also at national level. The type of energy analysis is linked to the purpose to be carried out. A new building design is used to model and foresee the behavior of the building before the construction. The energy performance certificate aims to target the energy performance of existing buildings based on reference parameters, while the energy audit seeks to assess the actual energy behavior of existing buildings in order to improve their performances. So these categories are reflected in the talent classification by the Unit ES 11300, which identifies 3 types of ratings. Design and asset are based on conventional climate and use, the former on planned buildings, the latter on existing ones, while the tailored rating is instead based on climate and use adapted to the actual building. So one of the main technical evolutions going side by side with the PBD series has been the improved level of detail in the building energy modeling. Starting from a seasonal evaluation, standards moved to a monthly semi-stationary method and then introduced the hourly dynamic one. The semi-stationary method of the Unit ES and hit with the introduction of correction coefficients to approximately take into account thermal capacity and the use of heat gains. In the hourly method introduced by the ISO 52016, the concept of nodes is outlined. They are specific points characterized by a thermal inertia and temperature varying in time. At each node, an hourly energy model is made according, a balance is made according to the resistor condenser system, and the heating and cooling needs are calculated basing on the operative temperature that comes from an overall energy balance of the thermal zone. So the Hartley step of the dynamic method is ideal to reproduce both climate data and the description of the building users and systems. We can manage the plants in three ways: free running, not considering the activation, constant or variable power, with plants intermittence. It is crucial to develop a strong ability in reading and communicating the outputs, from the energy loads and needs to the Hartley trends of temperature, and also to take advantage of them in the design stage, especially, so looking at the possible strategies to be adopted on the building. The theoretical part was followed by two case studies. The first consists of an energy audit on an existing building in Casale Monferrato, Piemonte, to evaluate its winter energy performances. The data collection operation made alongside with Unit experts regarded the building envelope and plant's characteristics, heated and non-heated thermal zone identification, the energy consumption and builds from the building manager, and on-field measurements. A 3D model was made in Revit in order to return the quantitative amounts of opaque and transparent structures, and also the characteristics of the surroundings. Thermal zones are assigned one to each floor. The energy models were made in the Unit software programs, in particular Leto for the semi-stationary analysis and Icaro for the dynamic one. The thermal properties of opaque structures were obtained through on-field measurements, and thermal bridges were after that calculated analytically. The model validation compares the energy consumption of the models with the real consumptions through the evaluation of the heating performance index parameter. It is given by the ratio between consumptions and the degree days. Models are validated if the margin of error is within 5% with the real consumptions. And as for the evaluation of the APH real, I opted, instead of the conventional value of 20, a range of temperatures between 20 and 18 degrees. This to take into account the fact that temperature can lower below the 20 degrees value due to the fact that plants do not work constantly for example, the night shutdown of the systems. So this range strongly influences the results, as we can see. Basing on the same energy consumptions, low is the temperature assumed internal, and higher will be the APH value. What about the models? The semi-stationary one and its dynamic counterpart running at 20 degrees, D1, fit in this range. The following models tend to stay in this gap with a couple of exceptions. The introduction of intermittence in D2 decreases the energy consumptions, and so in the following model, D3, it makes it reasonable to increase the set point temperature at 21 when the heating system is on. The introduction of new and higher internal gains in D5 decreases again the energy consumptions, and this is then settled in the last two models working on the ventilation parameter. So outputs are encouraging, as the APH values tend to stay in the real range or out of it within an acceptable limit, and this supports also the initial conservative choice of a range instead of a single value for the internal set point temperature assumed. So, is the Hartley dynamic method more effective than the semi-stationary one in the winter energy audit of a traditional existing building? Well, no. In this case, the semi-stationary model shows an optimal reliability, and even if it is less detailed, that's enough to describe the energy behavior of the building in the winter season, at least. The second part concerns the improving scenarios interventions, from the envelope insulation to the window substitution. Comparing S1, D1, and D7, we can see that the semi-stationary model decreases its consumption much faster than the dynamic ones. And with respect to D7, even D1 tends to decrease its consumption quite faster, at least in the first two scenarios. But any consideration has to be based on further analysis. So for example, we want to understand why D1 and D7 APH values tend to get close in the last scenario, the window substitution. So checking the individual loads, we can see that the window substitution equally reduces solar gains and transmission losses, because new windows are the same in all the models. But the D7 model has also a marked reduced in the ventilation losses due to a different ventilation profile. So is there now any remarkable difference in the improving scenarios among the two methods? Yes, the semi-stationary model tends to lose some reliability, so underestimating the heating needs, as the initially significant heat losses by transmission are reduced by the upgrading of the envelope performances. The second case study took an existing office building in Milano as the base for a theoretical work of comparison among the methods. A 3D model is again made in Revit, and in this case, each of the two floors analyzed, the 6th and 7th, was just divided into two thermal zones, according to the orientation. The energy models were made again in the ANIT software programs, but in this case, the components, the characteristics of the components were made available by the construction company of the building. So comparing the semi-stationary monthly average power demand to the dynamic hourly trend, here is what we get along the year. And focusing then on a limited period of time, we can now appreciate the differences. For example, the cooling needs along few days in between June and July. But we can go deeper in the analysis of the dynamic potentialities. For example, looking at the correlation between energy loads and needs. So starting from internal gains, and with the model with constant internal gains, we can see what happens as we assign a new detailed and higher during the weekdays profile. So their weight is fundamental, especially in buildings with high occupancy density and appliances load. We were also able to understand the differences in terms of solar gain between differently exposed thermal zones. So their impact on the daily peaks and also, of course, on cooling needs. But also ventilation and temperature. So as the external temperature goes beyond the cooling set point limit, here is 26, the ventilation contributes to the increase of cooling needs. We can simulate, for example, what happens increasing the external temperature count of climate or of the distance between the building site and the place where climate data are collected. So is the hourly dynamic method more effective than the semi-stationary one in the energy analysis of a glazed building with high free heat gains? Definitely yes. It is way more powerful, not only because for this case study typology, it provides more detailed results, but also because it allows us to understand them, so helping to identify where to focus the attention. And to further stress this dynamic effectiveness for this case study typology, a thermal comfort analysis is presented, so evaluating the operative temperature in free running conditions. We know that users are able to adapt their comfort range, but within certain limits, according to their different degree of acceptability, that is here represented by the different comfort boundaries. So this has a positive effect on the number of comfort hours along the year, and especially in summer. So starting from an hourly based representation of the dynamic result, we make some preliminary assumptions of the design strategies to be adopted. And this is another way to take advantage of the dynamic method. So this case study was useful to run an in-depth analysis on the building energy modeling characteristics concerning the calculation methods, in particular the Hartley dynamic one. And referring then to the Italian classification, regulation, and standards, we can say that the main output, the main result of this research was outlining the most suitable fields of application for the method. In particular, its use is recommended for requisiti minimi and criteria ambientali minimi in case of new construction and important renovations, which require verifications such as the cooling performance index. It is necessary for new construction as the building doesn't exist yet, the field of energy modeling is almost illimited. It is not necessary for energy performance certificate, since it is a user-independent tool and got a designing purpose, but a comparing one. Thus, the importance of the calculation method hasn't got actually a leading role in this case. And then it is both recommended and useful for energy audit. There is a great chance to test the dynamic approach. Indeed, a calculation method whose results are proven to be comparable with the real ones is a strong indicator of the applicability of our tools also to new construction projects. For course, we still don't have any result yet. Thank you for the attention.
Thanks to you, Marco. So now the problem is that your opponent, who is Professor Salvalai, is not available. And since he did a very good presentation of your work, we have two chances. Or we ask for last-minute opponent online. I don't know. I suppose that either Rossano or Francesco or even Michela could add or some comment about this work, or I don't know, Andrea, you pull off your hat of supervisor and become the most evil person online.
I have asked a lot of questions to him during the past week, so I think he is not so happy to answer again to other questions. So, Presentazione would like to... Sorry?
It was a good path.
Francesco, yeah. Anything to ask?
Yeah, I have maybe a general question. I didn't understand if the, let's say, the final finding of your work is that in order for, let's say, massive building, residential massive building, we should, a designer can, with a good level of confidence, use a semi-static, semi-stationary model to get good results of analysis. Whereas in the case of low massing building with a strong correlation in loads by internal and solar gains, you should definitely only use a dynamic model. Is this the final conclusion, or maybe something different?
As for the practical part, the main conclusion was that while the dynamic approach can be adopted on several situations, both existing old buildings and the new ones, the semi-stationary is instead more adapted to buildings with high consumptions, especially in the winter case. So with low insulation properties, for example, because as soon as we increase and upgrade the energy performance of the building, it tends, and so as we decrease the thermal losses by transmission, it tends, this method, the semi-stationary one, tends to lose some reliability.
Okay. And is it only concerning the building envelope dynamics, or there is also, did you do, but probably you didn't do any consideration about the building systems modeling?
No, actually not. I took because the dynamic software I used does not concern the systems, but what I did is to take the efficiencies of the systems in the first case and to apply the same values also to the dynamic, but I didn't run any system analysis on the dynamic software.
Okay, because perhaps another good reason of using a dynamic system is also to better set up and do consideration about the building system management.
Sure. Sure.
Yeah, thank you.
Okay. Thank you, Mark.
Thank you, Marco.
Bye.
Bye.